This is a practical about hardness, the hardness of materials. Hardness is the ability of that material to withstand plastic deformation, which, you'll remember, is related to the yield point and to the work hardening capacity of that material. The way that we measure hardness is by pressing and therefore indenting the material that we're interested in with another harder material. And that harder material would be diamond. The indentation is made with an inverted pyramid. So the diamond is shaped as an inverted pyramid, 4 facets coming to an apex. And the yield stress at that apex, which is related to the radius of the apex, is very high. Therefore, the yield stress exceeds that of the material that we're interested in, and therefore the plastic deformation is confined to the material that we're interested in. What we then do after the indentation has been made is to measure the dimensions, and from the dimension we can calculate an index. The index that we'll be measuring today is the Vickers hardness. The instrument we use for measuring hardness is this, no surprise, hardness tester. We place the polished section on the stage and we need to bring it into focus. And the best way to do that is to find the interface between the sample and the resin, and then adjust the stage so that it comes into sharp focus. What you see are 2 parallel hairs. The hairs are then adjusted. Well, the right-hand one is adjusted to be superimposed on the left-hand hair. When that's in position, we move our section well into the sample, and let me find a place where we don't have a scratch. There. And then turn from the lens to the diamond indentation. The indentation piece is a load is placed on it, and that load is adjusted with this dial. So at the moment it's set at 1, we can turn it to 5, 10 or higher. And what we'll do is to place a 5 kilogram load on this test piece because we're dealing with brass. And then we're set to go. All right, and that's now complete. Then we turn once more back to the lens so that we can see the diamond that we have. We adjust the hairs so that the left-hand hair is at the left corner, and then move the hair on the right-hand side across to intercept the right corner. And then from the dial we read what value we have, 229 microns. Then we turn the eyepiece round 90 degrees, adjust the hairs so that the left one intercepts now the lower apex, and then adjust the right one, which is now at the top, so that intercepts the top apex, and then once again read off, and we have 232 micron. So with those 2 numbers, plug them into the formula for Vickers hardness, and you will now have an index for brass. You would repeat it for any of the other test pieces that run through this tester, which in your case is aluminium, copper, and mild steel. That concludes this practical.